All right, welcome to 6.1.2 Polygon exterior angle sum. I normally actually start this class with a warm up of yesterday's stuff because yesterday's stuff is really important. So I've got 4 problems here that I would recommend you pause the video and try. Yesterday's stuff again said that the sum of the interior angles of any polygon totaled up to n minus 2 times 180, where n is the number of sides. See if you can pause this and figure these problems out. All right, let's start. Finding A. Hopefully we know there's 180 degrees in a triangle. We could use this formula for that, but I think we don't need to. So I know if I add all those angles up, they should add to 180. So A plus the 65 plus the other 65, that should be 180 degrees altogether. Well, 65 plus 65 is 130. So A plus 130 will equal that 180. So then just subtract 130 from both sides. A is equal to 50 degrees. Let's do the same thing to find B, but B is not in a triangle. It's in a 4-sided figure, so I might have to do that n minus 2 times 180 thing first. I have to say, oh, I've got 4 sides, so 4 minus 2 times 180. That'll be 360. So I know all these angles there, they have to add up to 360 degrees. So let's write that out. B plus all those other 3 angles. I'm just going to add those now. 100 plus 110 plus 105, that's 315. So B plus that 315, that'll have to equal 360 degrees total. So just subtract the 315 from both sides. B is 45 degrees. Let's put our work over here maybe. All right, let's try it with this one right over here. That's got 6 sides. So if I wanted to find its total add sum, it'd be 6 minus 2 times 180. That's 720 degrees, I believe. I'll double check. Yep. So that means if I add all these angles up, that'll add up to 720. All right. Well, I've got 2 C's. So 2C plus, let's add up all those. 135 times 4, that adds up to 540. If I add all those angles up, it should be 720. So then subtract 540 from both sides. 2C would be, let's see, 720 minus 540, that's 180. And then just divide by 2. C is 90 degrees. All right, one last one. That has 1, 2, 3, 4, 5 sides. So to find its total angles, I'm going to do 5 minus 2 times 180. That is 540 degrees. So that means if I add all those angles up, they should add up to 540. Well, they're all the same angle because they've all got those tick marks. So they're all angle D. There's 5 of them. So 5D should equal 540. And just divide by 5. D equals 108. All right, this is just a review of yesterday's material. Make sure you remember that n minus 2 times 180 for the interior angles. It's going to be important. Today's essential question is about the exterior angles of a polygon and what they sum to. So first, we're going to have to talk about what an exterior angle is. An exterior angle is formed on the outside of a polygon when one of the sides is extended. So this is an exterior angle. It's on the outside of a polygon. All right. Set of exterior angles. A set of exterior angles all face the same direction. It kind of looks like a windmill. So I've got 2 examples below. Which one shows a set of exterior angles? Hopefully you said this one on the left because they all kind of go in that clockwise order, right? They don't, this one is different because like they're both on the inside and this one's over there. So if you have a set of exterior angles, they're all going to be in the same order. So they're like this one goes here, goes there. They kind of go in a circle like this. So that one's no good. This would be it. All right. Now we're going to talk about the exterior angle sum conjecture. We're going to find out what these exterior angles sum to. So if I added that and I added that and I added that, what are they going to add up to? It's actually going to be a lot easier than yesterday's one, which is kind of interesting. All right. So to help us out, I've got a little worksheet we're going to work through, and hopefully it'll make sense. So first off, the top one's filled out for you. It had a triangle. It found out all the exterior angles, and it found out that for a triangle, the exterior angles summed to 360. Let's do the same thing for a quadrilateral. I'm just going to write quad for quadrilateral. A quadrilateral has 4 sides. The sum of the interior angles we figured out before, that's 360. So I can use that to figure out this one here, right? I'm just going to take the 360 and subtract off all those other angles. I get 140 degrees. All right, but what I really wanted was I wanted to look at the exterior angles. So I should be able to figure out which each one of these exterior angles is. And I should be able to figure it out because all those exterior angles form a line with the interior angles. And we should know that lines always add up to 180 degrees. So if this one's 70, that's 110, because 110 plus 70 is 180. If this one's 75, that'll have to be 105, so that it adds up to 180. If this one's 80, that's going to be 100. This one here, that'll be 40. All right, let's add up those exterior angles and see what we get to for a quadrilateral. 110 plus 105 plus 100 plus 40. When I add all those up, I get 360 degrees again. All right, let's try it with a pentagon. I'll just put pent for pentagon. Pentagon has 5 sides. If I did that 5 minus 2 times 180, I think we did that earlier for the warm up. That ends up being 540. So I know those inside angles add up to 540. So I could use that to figure out this one that they didn't tell me. Let's see here, 540 minus the 70 minus the 160 minus the 90 and minus the 110. That leaves me with another 110 degree angle there. All right, let's take a look at what my interior angles are then. Or the exterior angles, I'm sorry. That exterior angle will be 70, so that they add up to 180 with this one, right? This one will be 110. This one will be 20. That one will be 90. And that one will be another 70. All right, let's add those up. 70 plus 70 plus 110 plus 20 plus 90. When I add those all up, I get 360 degrees again. Turns out the exterior angles of a polygon, no matter what polygon it is, when I add those exterior angles up, they will always, always, always sum to 360 degrees. So I'll come back to this in a minute, but right there, the exterior angle sum conjecture, for any n-gon, the sum of the exterior angles is always equal to 360 degrees every single time, no matter how many sides it has. One way to see that is, I've got a picture here. If you could imagine this hexagon shrinking smaller and smaller and smaller until it was just basically a dot, you'd still have all these exterior angles there, but they would be shrunk down so your pentagon was so tiny you could hardly see it, and those angles would come out like this. And you could see that when you added them up, they form an entire circle. And there's 360 degrees in a circle. So one way to see why it is no matter how many sides you have, you could always shrink it down to like a size of a dot, and those exterior angles would then kind of look like this, and you can see that they add up to 360 degrees. So that's one way to see why it always happens. All right, let's do a couple examples, then we'll be done. All right, so I could try to find all these interior angles and use that to find x, but now that I know the exterior angles sum to 360, it's a lot easier. I know that if I take the 85 plus the other 85 plus the 120 plus that x, I know if I add all those together, I should get 360 degrees total. So then it's a lot easier to add up. Let's see here. I'm just going to do the 360. I'm going to subtract each of those in my calculator. So 360 minus 120 minus the 85 minus another 85. That's 70. X is equal to 70 degrees. Let's try this one. What is a measure of each exterior angle of a regular nonagon? Well, a nonagon has 9 sides. And I want to know each angle. Well, I know if I add them all up, it'll equal up to 360 because I'm looking at the exterior angles and they always add up to 360. So if I had all 9 of those angles, let's say 9n for whatever the size is, if I had all 9 of them, I know that's going to equal 360 degrees total. So if I wanted to know what just one of them was, divide by 9. One of those angles would be 360 divided by 9, which is 40 degrees. Okay, example C is going to look a lot like this one here. So for this one up there, we had, that was 9 was the number of sides. And that n was the measure of each angle. Each exterior angle to be precise. And I know if I take the number of sides times each exterior angle, that equals 360. We're going to do that for this too, except this time I don't know the sides. It says if each exterior angle measures 30, how many sides does the polygon have? So we're going to do the same type of thing, except this time we're saying I don't know how many sides it has, so I'm going to take that S. But I do know how big each angle is. Each angle is 30. So S times 30 should be 360. Divide both sides by 30. And S will be, let's do that with a calculator. 360 divided by 30, that's 12. There are 12 sides in that polygon. All right. Hopefully that was okay. Today's worksheet is 6.1.2, polygon exterior angle sum. The big thing with this is recognizing that the exterior angle sum always, always, always sums to 360 degrees every single time. There will be some interior angle sum problems, so don't forget that one. That one is hugely important. The interior angle sum, again, was the formula n minus 2 times 180, where n is the number of sides. All right, I'll see you in class.